Hello everybody and welcome back to our physics engine programming. We are coding a physics engine from scratch using C# and Monogame. All of the source code is going to be available through GitHub, and I'll have a link in the description for not only the physics engine itself, which is called Flat Physics, but also the Flat library, which is kind of an add-on for Monogame that we created on this channel that we can use to draw two-dimensional graphics. But we're going to continue our supplemental video here. I'm kind of taking the code base we have and I'm making changes and updating it and making corrections to it as needed. And after this video, I think the next thing I want to do is work on completely separating the broad phase and the narrow phase of our collision detection and resolution. Right now, there is still a little bit of collision resolution inside the broad phase, and I want to get that out of there. So maybe that's something for the next video or maybe the video after, but we'll see how that works out with the code we're doing right now. So I have a to-do list here. This is not the main physics engine to-do list. This is just things that I would like to have done before we move on. I've separated this to-do list by different files, and so I'm going to start with the game one here. The first thing I want to do is set the window position to 1040, and what that's going to do is actually just start the window position on the left side of the screen. And so inside this initialization code, let's just set the window position. Okay, so that'll make the window show up on the left side of the display when it pops up. So we're good with that first one. I can drop that out. Remove the vertex buffer array. So the vertex buffer array was something I had in the game class, and we were using that for drawing our vertices, and I'm not using that anymore. We actually have a modified draw box function that's taking care of all the drawing for us, so we don't need this vertex buffer array anymore. Okay, so I can drop that out of our to-do list. Next, remove old code in the update function allowed for flat body to be manually moved. Okay, so in our update code down here, we had some code in here that allowed us to manually move. Okay, so here it is. This code right here allowed us to manually move our entities, or allowed us to manually move the bodies for testing. We don't need that anymore, so I'm going to drop that out. And let's get rid of that out of our to-do list. We have a wrap screen function inside of our game class that we don't need anymore. Before we were using that because we wanted the entities to kind of wrap to the other side. Now we're not really using that anymore, so I'm going to drop that out. So here's the wrap screen function. Let's go ahead and delete that. Okay, our flat body removal code, I want that to disregard any of the static bodies. So if I scroll up here to the update function, so here's the code we're using to remove bodies once they pass below what the camera can see. And I actually want to disregard any static bodies. So if a static body moves outside of the display, I want to still keep it. So right here, I'm just going to put a check. So if the body we're getting is static, then we're just going to continue and we're not going to remove it. Any kind of dynamic body is fair game to be removed, but I want to keep all the static bodies regardless of whether they're in the view or not. Okay, let's drop that one out of our list. Change the camera zoom to 20. Okay, so I wanted to increase the amount of viewable space. So I'm going to zoom the camera out just a little bit. So let's go up to the initialization code. I've got the camera zoom at 24 right now. I'm going to set that to 20. Drop that out of our to-do list. Change the min and max size of the box and circles. Okay, so when we're adding boxes and circles, I wanted to change the actual size that we're doing right now. So I'm going to scroll down here to the update function. So every time I press the left mouse button, we're adding a box to the world. And right now we're using between 1 and 2 as the sizes. So the length of each dimension is somewhere between 1 and 2. It's just a random value that we're picking. And I want to change that to be 2 to 3. So we're going to change this to 2, 3. And let's do that for the width and the height. All right, then the circle minimax I want to do between 1 and 1.25. So here's where we add a circle. Every time I press the right mouse button, we're adding a circle. And I want the size to be 1 to 1.25. So the minimum is going to be 1, and the max is going to be 1.25. That looks good. Let's go ahead and drop that out of our list. All right, the last thing is I was possibly thinking of changing the ledge locations and dimensions, those slanted ledges that I added in the previous video. I'm actually not going to do that. So let's just go ahead and run this. So right now I've changed everything in the game class. I think that one changed. Let's go ahead and run this and just make sure it works like normal. And that looks good. Everything looks like it's working like it should. The window actually isn't positioned like I was hoping it would be. I was hoping it'd be a little bit farther down on the screen. So let's go ahead and change that. Okay, and actually what I wanted 10 and 40. So let's change this 4 to 40. And let's run that and make sure it looks okay. Okay, yeah, so that window position looks really good. And everything seems to be working just like it did before. This camera zoom is working still as well. So I'm going to delete the ledge locations and dimensions. I'm not going to worry about that. So next I've got an entity class that I would like to create. And actually I'm going to save that for later. Let's go ahead and continue down. We're going to work on the FlatWorld right now. Okay, so the FlatWorld class, let's go ahead and switch over there. All right, so here we are in the FlatWorld. Inside of our add body class, I had some old code in here that I was kind of testing out, but I'm not actually going to use. So I'm going to go ahead and delete this commented code. That'll simplify that quite a bit. Now, in our actual to-do list, the first thing I have here is when we're recording the contact points, so then we can actually see them on the display when they're intersecting, and we can display them. But the way we're doing it right now is actually not the most efficient. All right, so here's the step function. If we scroll down, we should see, all right, so here's where we're adding the contact points. If the contact count is greater than 0 is actually unnecessary, because if we're actually in this loop, the contact count is going to be greater than 0. So I'm going to go ahead and remove that if statement right there. Okay, and I'll just put debug in parentheses there, that this is just strictly a debugging feature. So now when we're actually recording the contact points, I only want to record the contact points for the last iteration. So if we scroll up here, we're running through multiple iterations and then moving it by this very small amount for each iteration, just to make sure the accuracy is really high for our collisions. And when we're recording these contact points down here, I only want to record the contact point if this is the very last iteration for our collisions. I'm just going to make sure this is the last iteration. If the current iteration, and you know what, one more thing I want to do is I actually want to change the naming convention here for this iterations. So instead of IT, I'm going to call this the current iteration. And let's rename that for the whole function. Okay, so now we have that called current iteration. All right, so the other thing we have, so this iterations value that we're passing in, I want to rename that to be total iterations. All right, so let's copy that and just rename all of the iterations to total iterations. Okay, it looks like we have one more down here. All right, so here we're back in the contact points list where we're adding contact points. If the current iteration is equal to the total iterations minus 1. And so as we're looping through, if the current iteration is the last iteration that we're actually on, then I want to record all the contact points. And so then we'll go into this, this if statement here, where we add them to the list. All right, so that takes care of those two. I'm going to drop those out of the list. Next, create a separate bodies function to apply the MTV and the narrow phase. Okay, so right here, let's scroll up here. So here's our collision step. We're looping through all of the bodies. We're checking if there's a collision, and if there is a collision, we're actually separating them using the minimum translation vector, which is the normal of the collision times the depth. And I actually want to take this into its own separate function. So let's go ahead and cut this out of here. I'm going to scroll right below this step function, or the step function in the FlatWorld, and let's make a private function, and this is going to be called separate bodies. Okay, and so we're going to pass in the two bodies that we want to separate. So we body A and body B. And then let's pass in a vector that's the minimum translation vector, and that'll be the vector we use to separate them. So instead of a normal and a depth value here, we're actually going to have an MTV. And the MTV is the normal times the depth. So this one will be a negative MTV. And then down here, we'll just substitute the MTV for everywhere we have the normal times the depth. All right, so now we have our separate bodies function. Let's scroll back up to our collision function. So right here, we're going to call the separate bodies function. Let's pass in the two bodies. and the minimum translation vector. So that'll just be the normal times the depth. Okay, and I like the way that looks already. It looks a lot better, a lot cleaner there, and kind of spells out exactly what we're doing. So something we're going to work on a little bit later. This is our broad phase part of the collision system. And we're still handling some of the collision resolution here. And I want to completely get rid of that and move this all over to the narrow phase. So in a subsequent video, what we're going to do is actually completely move this collide and separate bodies function out of here. And we're just going to record the pairs of flat bodies that are intersecting. But that'll be for another step. All right, so the last thing I want to do is actually create an entity class here. The entity class is something that's going to reside inside of our main game project. The purpose of the entity class is to associate the body with a game object. And in this case, it's the color. So if I go back to our main game class, every flat body has a color, and we're using a list right here to store those colors. But what I want to do is actually have a list of entities as a color and a flat body. So the flat body and the color are actually inside the same class, and they're associated together. Let's add a new class to our project. And again, this is in the main game class. So here's our flat physics tester. I'm going to add an entity class. And I'm actually going to call this the FlatEntity. For now, it'll be sealed, but we can change that if we need to. All right, and so we want to associate the flat body with the color of the flat body. And so let's make sure every entity has a physics body and then also a color. And then another byproduct of this FlatEntity class is we can then use this to do all of our drawing as well. So we can put all of the draw commands in a function here called draw, and then pass in the shape batcher to this function, and then use this function to do all the drawing for us. So that should simplify our code quite a bit as well, because we'll be able to just call this for every entity. Let's go ahead and make our constructors. The first one, I'm just going to give it a flat body. And then this constructor will allow us to assign the body directly, and it'll just get a random color. And we'll just use the random helper to get a random color there. Okay, the next one is going to be the same thing. We're going to pass in a flat body, but I also want to be able to pass in a color. Now, the other ones are going to be a little bit more complex. I'd like some helper constructors that will allow us to create a circle or a box body. So the first one, let's create a circle. And then one more thing, I actually want to pass in the FlatWorld here as well. This is the main physics world. And the reason I want to pass it in here is once we create this body, I want this constructor to then add the body to our physics world as well. So let's create a circle body. We'll just give it the radius. I'm going to make the density just kind of a default 1, and the static will pass in here. Restitution will be kind of a default 0.5. And then let's pass out the body as a result. If there was an error, I'm just going to throw an exception in this constructor. If we get to this point, we actually have a valid flat body physics object. We want to set the position of this flat body. Let's record this body. We're going to save this body, and then we're going to add it to the world. So that's our entity creation for a circle. And actually, now that I'm looking at this, I think I want this color and body field, physics body field. I want them to be public and read-only. And so I'm just going to make these capital letters since that's what I do when they're public. And I'm just going to rename that for every instance in this class. All right, so the last constructor I want to make is one for a box body. So this constructor is going to look almost exactly the same as the last one, except instead of a radius, we're going to give it a width and a height. And in fact, I'm just going to copy this code and move it right down here because it's going to be exactly the same, except instead of the radius, we're going to give the width and the height. And then instead of creating a circle body, this is going to be create a box body. Oh, and actually one more thing, we need to set the color in these constructors as well. So just right here, let's just set the color to a random color. And we'll use our random helper to get a random color. So we create the body, we send it to the world, and then we get a random color for each body. The last thing I want to do is I want each entity to be able to draw itself. Right here, let's go ahead and set up the draw code for this entity. First, let's check to see if this is actually a circle or a box. And let's go back to our, we'll just go to the game class and we're going to copy the draw code here directly. So I'm going to scroll down to the draw function. All right, so here's the circle drawing code. I'm going to copy that. Let's get the box drawing code. Let's copy that. Okay, now the position, we'll have to go back and copy that as well. So the position is right here. And we're converting that from a flat vector to a vector 2, so MonoGame can use it. All right, so the body is actually going to be the body that we've assigned inside this class, or a reference to the class body. So let me just copy that, and I'll paste it in right here to all of these instances. Okay, now the colors array, we don't actually use the colors array. We're going to use the color field from this class. So now we have the complete entity class. Let's go back to our game class. And instead of having a list of colors, I'm going to have a list of flat entities. All right, so now let's make corrections to our game class. And so we're inside the initialization function. I'm going to get rid of the colors array. So after you create the ground body here, I'm going to create an entity using that flat body. So instead of adding the colors to the list here, I'm going to tell our entity list that we want to add a new entity. And I'm going to use the ground body as the body we want to add. Once we create a new entity with that ground body, it should give it a random color as well, but I actually want to assign that color. And I think this one was dark green. Here's our ledge. Let's do the same thing for each one of our ledges. Okay, I'm just going to copy this and use it for ledge 2 as well. And I think ledge 2 we had a dark red color. Okay, so then all of our static bodies are set up. Let's scroll down here. Now every time we press the left mouse button, we are adding a box body. I want to change this so it creates a box entity. So instead of creating a body right here, let's create a new entity. This is not static, and then we want to give it a position, and that'll just be the mouse world position. And then I can get rid of all of this code right here, and that cleans that up really nicely as well. So I like the way that looks. Okay, now with the right mouse button, we add a circle. And then I can just clean up all of that code. And that looks a lot better now that we have the entity list. Everything gets cleaned up there really nicely. Let's scroll down here and see the next error. All right, so here's our body removal code. Let me scroll this down here just a little bit. So here's where we're removing the bodies. We'll have to come back to that here in just a moment. We're actually now going to remove entities from the list instead of the bodies. We'll come back to that. Let's go down to the draw code. Now that we're drawing here, I don't need to actually get the bodies anymore. So we have this world get body. All we have to do is loop through all of the entities. I don't have to loop through all the bodies in the world. So instead of looping through all of the bodies, let's loop through the entities. I don't need to get the bodies anymore, and I don't need to, actually, I don't need to do any of this code anymore. All we have to do is get the entity, and then tell it we want to draw that entity, and then give it the shape spatcher as well. So that cleaned up the code quite a bit. We still have the contact points that we're drawing here, so I'm going to keep that in there. The last thing to do is the entity removal. And actually, before we work on that, I'm going to go ahead and comment that out and just make sure everything seems to be working just like it was before. All right, so we got an error, so body does not exist. So we're inside the entity class in the draw function, and I just had one of these body references that I forgot to change to the local reference. So we'll change that one, and let's run that and make sure everything looks just like it did before. All right, so we're getting an error because I actually forgot to create the entity list. So I have the entity list, but I never actually created it. So let's stop this. We're going to go up here, And we're inside the initialization function for our game class, and I just need to create the entity list. Let's run it and see how it looks. So everything looks exactly like it should. I don't see any changes. It's just our code is a little bit more updated and organized. Now the circles, I want to make it a little bit bigger. So I'm going to scroll down here to the circle creation. I'm going to make 1.25 the minimum, and the maximum is going to be 1.75, and let's see what that looks like. Okay, I think that I like that a little bit better. In fact, maybe that's a little bit too big. Let's do 1.25 to 1.5. Okay, so the last thing I need to do is actually handle the entity removal. So I'm going to have a separate list here that's going to record the entities that are scheduled to be removed. I'm going to call this entity removal list. So right here inside of our initialization function, let's create the list. And then let's scroll down here to the update function. So let's check to see if we actually need to remove an entity. I'm going to bring this comment back in here. Instead of looping through the bodies, we're going to loop through the entity list. And then let's actually get the flat body from this entity as well. So if now the axis aligned bounding box is outside the view of the camera, we don't need to remove the colors anymore since we're not doing that. But instead of removing the body from the world, I'm going to send this body to the entity removal list. And then I'm going to take away this. We don't need to remove it from the world right here. Every time the update loops, I need to clear the entity removal list. The removal list is going to be empty every time this starts, and then we're going to add entities that need to be removed, and then right here in a separate loop, we're going to remove those entities. So let's loop through the entity removal list. So what we need to do here is actually remove the body from the world and then remove the entity from the entity list. So the first thing we do is remove the body, or the physics body, from the physics world. And we'll just get a reference to that body from the entity. And then we'll just remove the entity from the main entity list. Let's go ahead and test this out and make sure it's working like it should. I'm going to drop a body over here, or an entity, and let's see if it gets removed from the list. Okay, that looks like it works. So we're at the body count 3 now. If I drop one over here, we're at 4, and then we're back to 3. That is our entity class. I can go back to our to-do list here. I'm going to remove this. So we're able to get through all of our to-do list here, except for that one thing. That'll be for another video.